I don't think I've heard the word rain mentioned so many times at the beginning of a conference. Coming from England, I'm very happy to hear this. Water conducts light, so all those raindrops come from the light umbrella above our heads. And I'm also reminded of Charles Darwin. He said that in order to think about new things or to think deeply, the best environment is a light drizzle of rain, walking with a friend, and he constructed a path at his house in Kent. It's called the thinking path. And one first route of the triangle, you have open countryside to your right and a forest to your left. The next line of the triangle, you have fields of corn, growing things, and smaller gardens. On the final path, he has his research gardens. That thinking path, walking around with a friend, talking, that was his ideal environment in which to think. So I'm quite happy it's raining. Now, the other thing that is important to me as an architect, fundamentally an architect, designer, is light. I describe it as the opium of the architect, and shadow is its form. So with that, I would like to thank Vanoncini for sponsoring my talk. The mind, where do you start? This is Paris. This is ingenious. It's not us. This is a tramp, somebody without a home. But I'm Scottish. And Scots people, described by Charles Wheeler, who got the Nobel Prize for Physiology or Medicine in the 1930s for the cloud chamber. In accepting the Nobel Prize, he said, "We Scots, we're romantic, speculative, and inventive, but with the mind of a chartered accountant." So economy, for me, is at the heart of the other things, most of the things I do. It's also at the heart of every act I do is that we do not own the project. It is a shared adventure with other people, and we always bring the other team players together before we start, except, of course, in my mind. Because when a client rings me up or I meet a future client, they have an idea what they want. I cannot ignore that idea, and my mind starts ticking. But in my mind, I've inherited certain things in the human DNA. We all have red, green, blue. Most of us. We can't escape it. But we also acquire concepts into our brains from the people we know, from the environment we live in, and from what we learn. And my approach from this first encounter with a potential client, who is going to be the user of the building, is to write. I usually write prose, and it's my way of investigating ideas. If I draw straight away, which is a temptation of an architect, you have locked an image in your mind which is very difficult to get rid of. With words, you can move them around a bit like an archaeologist with a toothbrush, looking for new things, and you are not fixed by the words. Sometimes I get to an aphorism, and from the late 20th century was that we seem to value shares more than we share values. And a recent one at a dinner, somebody said, "Well, give us one for the end of the evening." And I said, "Water connects the world but divides people." And these are ways of thinking before drawing. I then take a Chinese or a Japanese brush, which happens to be handy, and I do what I call architectural calligraphy. From that, sometimes, is the emerging form of an architecture. This house is 42 years old, built in a pig field. It has solar collection, preheating solar energy. It has a basement or a cellar where all the junk is stored. The slab floats and stores the energy. And this picture on the right is 40 years on. It was built for 800 euros a square meter in today's price. Nothing. Less cost than a social housing. It's a very light steel frame. It only weighs 10 kilograms per square meter. And I built it with my girlfriend. I was 27 years old when I started. Who gives a chance to a young person today of the age of 25, 26, 27 to build them a house, a building, or plan a city, as the fathers of Edinburgh did in 1768? They gave the Georgian Newtown plan to a 25-year-old person. So we have an obligation today in looking to the future to trust the young people, to give them opportunities, and in many ways to destroy what I call the official journal of the European Union's competition regulations, which favor only big companies, but was set up ostensibly to favor small companies. So I recommend there's a Dutch outfit and there's a British outfit which are fighting to bring new ways of procurement to young people. This is simply color in the landscape comes into the building at night in the winter. Color is further away in the summer, in the garden, comes closer in the winter. That was the first building I did. The first one I ever did in England was when I was teaching at the Architectural Association in London, and I invited the students I was teaching to come and build a house. Not the slab or the structure in this case, but everything else. And this is the house. It looks like it landed in a forest. It's actually in a clearing. But it has quite a sophisticated energy system. But this time, all the energy is collected through the roof, not the walls of the house. And that's what it looks like about 3 or 4 years ago. And as you can see, the fundamental goes back to light and shadow form making, and trying to make something which in my mind is aesthetically pleasing, but may not be aesthetically pleasing to some other people. In terms of inventions, there's a gentleman here, Frederic, who is from Saint-Gobain, but he's the Italian representative of Saint-Gobain. And I told him a story earlier about how we didn't work with Saint-Gobain when we could have done. This is simply a range of the evolution of what is now called either spiders by people or structural glazing with float glass that's toughened. We also did all glued assembly with UV coal, and that's something which has also reappeared in the last few years with other people in the world. That's the famous thing that Marco mentioned, the bioclimatic facades, which were a way of making sure that this huge building facing south did not lose energy through its south facade, that it actually was a stable, insulated, but nothing to do with insulation. It's just simply the exploitation and movement of energy. Then we did an all-glass bridge, and architects got very excited about doing glass floors and glass staircases and glass ramps, which led me to use a phrase in the 1990s. Architects say, glass is the answer, what was the question? Which means they don't think. In the same way that Cedric Price in the 1970s said, technology is the answer, what was the question? So today we have to move forward and think slightly deeper. And these are just, I'll snap through these, some of the other things we did with IMP in Paris, at the Louvre, and in Leipzig, the big glass hall. No air conditioning in any of these buildings, of course, apart from the Louvre. Leipzig Glass Hall has 2,000 square meters of opening vent at the bottom and 1,000 at the top, and it only provides heat where people are. But significantly, it has robots that clean it. And that was simply putting a question to the client, the Leipziger Messe, how are you going to clean the windows, the glass? And they said, you're going to tell us, Mr. Ritchie. So I said, well, up the road there are two men, they happen to be men, at Magdeburg Institute, Fraunhofer Institute in Magdeburg, who had started making little robots. So we got a commission from the client to fund them. Today, they are the leading center for robotics in Europe. And that, again, was somebody trusting me, and I trusted the kids to go for something. And good things usually happen because younger people are much more motivated, less precious about whether to please or displease people, and they have far more open minds. And here in Renos Sofia, we use the edge of glass to transfer wind load, so there's no structure in the corner of these towers. And in the development of the technical fixing of glass, but I wanted to create a lake and a wall. So there is virtually, in perception terms, no building. So you come up to it and you see a wall. There is no heating other than trace heating, and there is no cooling other than one pipe running along the top of the wall, which drips water down the wall on the inside to feed the plants, and you get summer evaporative cooling. That's it. And we exploited the Gabion idea further, and even a 2-speed rowing tank, because if those in the audience have ever rowed a boat in a rowing tank, the water comes straight back at you. So you have a novice speed and an Olympic level speed. And the world of form, this was the EDF in France, had, with the French government, committed to spend a lot of money making energy. This goes back to the 1950s and nuclear power. But they also committed to sending lots of electricity to Spain across the Pyrenees. And some English families living in a beautiful valley said, "We do not want your pylons." And from an energy point of view, back in the 1920s, 30s, pylons were like great big grey monoliths climbing across the fields and the landscape. And everybody said, "But I get a light bulb at the end. So I'm keen on these big Goliaths." Aesthetics change. People don't want them anymore. A bit like the Eiffel Tower was hated, now it's the first protected structure in France. So we designed these. They're called fougères. They are simply a shell structure. The French asked us to name them. So I said Faraday. No, he's English. I said France. Too brutal. I then said fuck, since people don't like these pylons. And they said, nah, smart, but not right. So anyway, it's like a fern that's unraveling. Anyway. And that knowledge of explosion forming and other techniques led to the Spire of Dublin, which is a tall structure. And then we moved to weaving buildings. This is, if you like, for me, the real birth of getting beyond wood as the only haptic thing that we can touch. I remember glass, and you get mist. If you put the kettle on, you get mist. So you don't need to spend money on a curtain. You can have a 5-minute bit of kettle. But one thing that glass has is you can kiss somebody else through it. It's the only building material I know that you can actually emotionally kiss somebody. However, touching buildings, wood, yeah, it's fine, it's haptic. How does the mind work? And why is it important between hardness and softness? And this building is woven phosphor bronze. Basically, that's bronze. Phosphor bronze, a bit of copper, and a bit of phosphor. It becomes soft, and it changes color, it's darkened. And in this circumstance here, in Plymouth, it's by the sea, and the winds blow hard, and the sea comes with the salt. And this mesh filters it and makes it go into a vapor, so it can then be collected. But the beautiful thing is, there are seagulls, well, gulls, and other birds, and they shit when they fly past. And the guano, their shit, lands on the copper, on the bronze, and you get fluorescent greens and whites and golds. It's like nature's own version of a Jackson Pollock painting. And Jackson Pollock, by the way, was the first painter to use physics. He used gravity to do his paintings. And in Italy, we won a competition, Alba di Milano, in which we used a new woven material of fiber optics and stainless steel wire. Unfortunately, the Minister of Culture in Italy objected to it, even though he was the original person who chose the site. So after 18 months, it vanished overnight. And Marco knows where it is. But it's also a privilege to have your artwork removed. Doesn't happen too often. And in Shakespeare Land, where I've been a governor for nearly 20 years, we managed to build a 1,000-seat theatre in 15 months and nobody's more than 15 meters from the stage. Now that's important at one level because voices then don't have to be really thrown. And secondly, can you do it with people that close and still see all of the eyes and not have too much of a steep view to see the eyes of actors? So this is where I wanted to get to, and you tell me if I'm going on too long. Yeah. The Sainsbury's Centre, Wellcome Centre for Neural Networks and Behaviour. We won this competition, ironically, through an OJU, and we're not a big firm, and we'd never done a laboratory before. But they asked us for a strategy for the next generation of neuroscience laboratories. Since we knew absolutely nothing, we did not speculate on what the answer could be, but simply wrote a poem, wrote a research program, how to get to the other end with the right answers. And we won after 6 months of not drawing a single line of a building. The two other final competitors, very well-known architects, came in with models, even detailed models of the laboratories. And one of the jury members, I found out afterwards, asked the question of one of these very well-known architects, will we have, as the user, the opportunity to design the cushions? Something to sit on. That was my poem. We're not magicians, we're dreamers. But significantly, space is here and out there. It is a continuum between the inside and outside of the mind, both mental and physical. And so ever since this period, we design with the mind in mind. So we have to learn, how does the mind understand things? Research. So we embarked on a 1-year research. This is the oldest drawing I could find, where man is contemplating himself. 1543. In that period, people also thought that knowledge came out through the eyes from the brain. And you also had Descartes in the 1660s. And of course, Descartes, the great French philosopher, managed to split our minds from our bodies and split us from our environment. So he's been a disaster as a philosopher, and we're still trying to recover from him. At the level of research, on the left is a picture of a 2-photon microscope taken 5 years ago. I can say now that that 2-photon microscope is now 1 centimeter by 1 centimeter by 1 centimeter. That one is a meter by a meter by a meter. The whole world of research and investigation into the active brain and neural networks of our brains is real. And what's interesting is that tiny little thing is looking into the future, whereas the Hubble telescope is looking into our history as far back as it can go. So how does the brain understand space? John O'Keefe, who was our acting client, as the acting director for this project, he had spent 40-odd years looking at the hippocampus, not looking specifically for anything to do with space, but why is the hippocampus so significant to our evolution and even today? So they do experiments, the location of the hippocampus, and what he found was the place cell. And then the two of his other postdoc researchers, Norwegians, the Mosers, found the grid cell. Then they found the border cell. And then an American found the head direction cell. Now the place cell, if all the lights went off here and it was dark, we would all find our way out. We have taken the information in through these 4 types of cell. The border cell one is the one that interests me the most. I think the first 2 are predominantly our GPS. The border cell is when you travel through a door from outside to inside. And this is, interestingly, right now, one of the problems of why VR is not, virtual reality systems are not cheap enough. Because the network, if you like, the software network, in order to go from in here to out there, is actually quite tricky to write. And the head direction cell is obviously where you're looking. Fascinating. This is the real shock. 90% of the information that we get comes in through our eyes. But the brain only uses 10% of it, because the rest we've already got, which is why it creates illusions, deception, and all these other characteristics, and the brain fills in automatically what you think you're doing. So in a way, it's like artificial intelligence that we're learning now. If you go on Google or something, it'll tell you, oh, you must watch this film next, or listen to this music next. It's how our brain works at a certain level as well. But the other interesting thing is our brain did not evolve to understand the environment. It evolved to understand each other. And its first emergence, if you like, was in the trees with apes and the understanding of movement in trees. And one ape watching another ape begins to think for the first time in a different way as against simply react as a natural being. He's watching movement. He's watching the beginnings of communication. And that's how we have evolved in terms of our brain. And the other surprising thing, and this is relatively recent, it's about 15 years ago, not much more. If you take the rods and cones out of a seeing eye and brain, you can still see. Because the rods and cones don't deal with black and white. And this was a very simple experiment done on a blind person. And the professor that did it was Russell Foster, who's the professor of circadian neuroscience. That's your daily 24-hour cycle, if you like, of circadian neuroscience at Oxford. So how do you go about designing a building when you're learning so much about how your brain is reading space? That's where we started. That was my first inking with the brush. Don't know anything, but there's a glimmer of hope that we might get somewhere. That was the first plan drawing, which showed the possibility of having a laboratory with a highly sophisticated research facility, together with interaction space and write-up space. And in a sense, it's the merging of those in the middle. Can you organize that spatially in the section of a building? Sometimes. A lot of architects assume if you put a hole through a building and you make an atrium, you have communication. That's garbage, because you can only see the edge of each floor when you look up or down, so you can't really see anything. And then it's organized horizontally at 2 levels. Each one is double height, so it's like double height houses on 2 levels, connected throughout. So we designed this building from the standpoint of the users, the scientists, and we had 2 types of scientists. Theoretical computational neuroscientists, they don't actually, I don't think they were born in our galaxy. They're extremely bright. It makes autism look normal. And you have experimentalists. And the main aim behind this one was to get the theoretical guys who are like monks to meet the experimentalists to create the new conversations. And neuroscientists like conversations. That's their origin of ideas. So you have to make even a staircase or a fire escape stair that they might want to use in the same way that in a music school, a musician might go into a fire escape stair because the acoustics are good. Space that's slightly more generous where they can stop, talk, and write when they're having a conversation. Especially the theoretical ones because they're mathematicians. So we worked out a way of making space that seemed to flow one into the other and was always a little bit more generous. The adaptability of space, you'll see there are no ceilings here, it's only to do with acoustics. They can turn this into what they want. So we designed a system whereby the scientists could build their spaces, not rely on the university maintenance team to come along and build a room. Because they're smart, they're physicists, electronics engineers, chemists, they can do all of this. The next level is the services. How flexible can you make services? And you've got something like 6 medical gases and 20 other services. Again, can you arrange it in such a way that they can access? You've got zones of 3 meter by 3 meter where you've got valves. They can do what they want. And they do. They make spaces which are completely different. And it's very nice. Wayne McGregor, the great choreographer, turned up. He wanted to work with the neuroscientists. And I asked him a question. Have you ever tried working at high speed when you're creating a dance? And he said, yes. Right now I'm working with the Red Arrows, which is the flying team of the Royal Air Force. Every country has its flying team. At 600 miles an hour. Getting them closer and doing more different movements. So each space, even the way you eat, like a room like this, becomes a laboratory. And then you have more formalized spaces. And there are 4 gardens. They can just go and eat, play, do what they like, where they like. But one thing that was fundamental in there, and I don't know if I can find it, not really, no, is the inside of the cladding of the building lets light in. You can see it coming in as diffused light. We asked the scientists, would you like a window to open? And in an audience of 500 PIs, principal investigators, one said, you must be joking, Mr. Ritchie. If we spill some mercury, it'll kill somebody on the pavement. Another scientist said, you're joking, Mr. Scientist. Of course we want opening windows. And if Mr. Ritchie says we can have them, we'll have them, please. So we created opening windows. More difficult to handle the air because we have sophisticated things. We have 3 air systems, but we introduced into the UK a thing called demand-led ventilation. And there's a system that we had to get through the European codes. It's called air acuity. And what it is, it has sniffer dogs in the air, in the ducts. So they can pick up the different chemicals. So if there is a risk, the air rate changes. So the air rate in the laboratories is exactly the same as it is in here or in an office. And it only changes if there's an issue. Normally, labs run at 12 air changes an hour, which is completely and utterly insane. So the concept of the outside envelope, I 2 years ago went on a journey with a Russian research vessel looking for microplastics in the Arctic Sea, and there weren't any. Last year's expedition found some, so even the Arctic Sea is now polluted from our other oceans. So I was interested in the fact we have climate change, and I'd experienced the Arctic Sea previously, and I was fascinated by the way that icebergs form off glaciers. As they fall into the sea, they rotate through 90 degrees, and these vertical lines are the lines of oxygen, you see on the left picture, escaping when they go into the sea. And they form these lines. And that image stuck with me when I first saw it. So we designed a facade which has 1 million downpipes for the rain. But they're microscopic. They're only it's like a wave, a sinusoidal wave, only 2 millimeters high. But it means we don't have rainwater collection. We don't need to have a cleaning system for the building, because the crest always stays clean with a little bit of wind, the rest comes off. And even arguing with the client and the University College London, you have to have a maintenance system, Mr. Ritchie. And I said, no, we're not wasting money on maintenance, it's for the science, the scientists. And we also developed this skin that's insulated, lets in about 10% of the light, but everywhere in this building, including the cladding, the scientists can write, except on paint. And the paint in the ceiling is the color of this screen. And it's at 480 nanometers wavelength. And that wavelength is the one that triggers our circadian rhythm in the morning, and you find it in the morning sky, even subtly when it's raining. The public side of this building is a colonnade, essentially, and this wave down the street. You only see the building tangentially, and it's a Georgian area of London, so you need the vertical rhythm to come into it, which we've got from the cast glass. And this whole new system of glazing is structural cast glass, which is, if you like, half the cost of float glass, and it is structural and carries the windows as well as itself. So it's the next revolution since 1985 at La Villette. And we hung some pixels, and you have Bach's musical offering to Frederick the Great, considered by some as one of the greatest compositions of the human mind. And you look in the other direction, you see portraits. And they come at the sweet spot because your brain's filling in the gaps. And those 11 portraits are Nobel Prize winners who've had part of their anatomy at some point inside University College London. And the next Nobel Prize winner will come out of this building, was the ambition. Unfortunately, in 2014, the man we were working with, and 2 or 3 others, was given the Nobel Prize. So we went to Stockholm and got drunk. And these are 5 animations along this colonnade, which illustrates to the passerby the way the brain deceives you. It's also a building that is white in the daytime and white at night, or a warm white. Most buildings, all windows in the daytime are dark. And at night, all you see are light fittings when you look up, which is pretty awful. So in both cases, I don't think architecture has really started doing anything sensible in the urban environment yet. And the light plays because of these rivulets, this folded, micro-folded glass. You get wonderful plays of light. And on the back, we played with the wind. We let the wind change the shape of the building. And at the end, they can project from a projector images of neuroscience. That's a neuron exploding or activating itself. And we did a little animation, a bit like the building became a brain. So does it work in the end? The building was first occupied in 2015, and it's been described by the scientists as very similar spatially to what neuroscientists in the world now understand to be the scale-free network of the brain, which is why we can go to the minuscule to the expanse. We can go to the 4 billion years ago with Hubble, as well as look at our own neurons and how they're behaving. The final illustration is the Royal Academy of Music, which we finished about 2 years ago, which moves us into the haptic qualities specifically. And it looks at the environment, the tree, and we're in Cremona area nearly here, and it's had obviously its disaster with trees. But my research was to find the best company in Britain at that time who was good at joinery, because our practice had never done a building with wood. Tricky. So we needed to learn from masters. The second one was, what was so special about the Cremona instruments? Was it the wood? Was it the way it's cut? Was it the way it's made? Was it the varnish? Because all of these things allow us to explore without designing a building. And then we looked at the inside of musical instruments, their architectural space, and you see light coming in again. And you think, we're going to be designing an opera house and a recital hall above it. That was the existing site, that's the proposed diagrams of how you organize buildings on buildings with old buildings. And we ended up with a theater. The light in the ceiling, every opera house in the world, most theaters have a chandelier. This is quite a small opera house, it's 350 seats for the students of the Royal Academy of Music. But they want to feel a big stage, and they want to understand that when they're making a sound coming from here, going through all the chambers and the shapes of our body to come out, the final, if you like, space before you hear the sound is the auditorium. And they wanted to feel expansive as well as intimate. So we blew up, we exploded the chandelier, so that it even goes into the walls. And you get a kind of galactic quality to it. And there you can see half crystals buried in the wall trying to escape the room to give dimension through light to the space. And I just want to show this is a little short film made by an architect in our office with another architect, Chinese, playing the music. The inspiration for the recital hall on the roof was, in fact, the bow of the cello and the way that you tune the strings. And that subtle reference, which the musicians don't see unless you point it out to them, but most architects see. And some architects recognize that the pattern of the copper on the roof is the same as the timber on the inside. So there's some books. I just wanted to finish by saying that as someone who finds staticity, it's a terrible word to say, statics, I've never understood engineers who talk about statics, because there's nothing static about anything in our world at all. Everything moves all the time. And I think the term active house I like. So it's also encouraging that explicit in the active house concept is also the recognition with which I agree wholeheartedly that simply erecting barriers, substituting air conditioning for open windows between us and the outside world that we evolved in and with, in the name of energy conservation, is not sufficient. Thinking level, not sufficient to ensure a healthy quality of life, physically or mentally. And I think I'm happy because my first two houses that I designed with these clients were both on the principles of orientation, making energy, storing it, recycling it, being friendly in the local environment, not using toxic materials, and being in sympathy aesthetically with the surrounding landscape. And the last thing I wanted to say, so if sustainability has been out there for about 100,000 years, it's been in architects' minds about 40. So it's out there. So we shouldn't be thinking about sustainability anymore. We've got it all. What we have to do is to understand how to use it properly, how to design properly. And that, for me now, is about the social value of what we do. Because if we come back to the way the brain is, it's our relationship to each other and understanding how our brains work much better. And I think there is a new paradigm possible in the way that we design buildings beyond the formulaic engineering view of energy and so on. And if I've spent 40 years trying to do things which are interesting and new, they're only for that purpose. And fundamentally, it's also about creating better performance from the spaces we make, the materials we use, and how we use them. And of course, trying to predict better. And now that the brain is right in there for me, predicting the brain and its behavior is fascinating. And I'm a long way, and everybody else is a long way off understanding any of it, really. But it's fun. Thank you very much.